Hey guys, welcome back to our channel. So this channel, Everyday Data Science, is all about trying to learn the different concepts involved in data science by practicing a lot of questions. In this video, I'm going to solve this question on LeetCode regarding investments in 2016 and try to walk you through how we can develop solutions to such problems. The difficulty level of this question is medium, and this question has been asked in Twitter interviews over the past couple of years. Okay, let's jump right in. We are given a table called insurance with 5 different columns: PID, TIV 2015, TIV 2016, lat long. PID is the primary key for this table. Each row of this table contains information about one policy where PID is the policyholder's policy ID, TIV 2015 is the total investment value in 2015, TIV 2016 is total investment value in 2016, lat is the latitude of policyholder's city, lon is the longitude of the policyholder's city. Okay. We are asked to write a SQL query to report the sum of all total investment values in 2016 for all policyholders who satisfies these two conditions. Have the same investment in 2015 value as one or more other policyholders and are not located in the same city like any other policyholder. That is, the lat lon attribute pair must be unique. We need to round the investment value in 2016 which for all those policyholders which satisfy these two conditions to 2 decimal places, right? Let's go through this example, right? So here we have 4 different policyholders and these are the investments in 2015, investments in 2016, and the city that they live in, these are the latitudes and longitudes, right? So if you see, the first condition is that the policyholder's investment in 2015 should be equal to one or more other policyholder, right? So for example, if you take policyholder 1, right? So policyholder 1 in 2015 invested, let's say 10 units. So is there any other policyholder in 2015 who invested this much? So yes, you have 3 and 4, right? And this is different than this. Similarly for 20, right, you don't have anyone else, right? So obviously by the first condition, this policyholder is eliminated for the calculation of investments in 2016. Why? Because this does not satisfy the first condition, that should have the 2015 investment value as one or more other policyholders, right? So now for first condition, we have policyholder 1, 3 and 4 in consideration. Now the second thing says that the policyholders should not be located in the same city as any other policyholder, right? So for policyholder 1, the latitude and longitude is 1010, right? Is there anyone else who is located at 1010? No, right? So they are still in consideration. 2 was already out. For 3, if you see, yes, so 3, 2020, and they are situated in a city where policyholder 2 is also there, right? So now 3 is also out, because this policyholder is not situated in a unique city, right? And for 4, if you see 40 is not anywhere else in this, right? So now the only 2 policyholders that are left for consideration is policyholder 1 and policyholder 4. So obviously for these 2, what is the investments in 2016? The total investment 5 plus 40, that is 45, and you need to round it to 2 decimal places, right? So that is what we are getting in the output, 45.00, right? So that is what we need to do. Okay, so to solve this, the first thing that we can do is try to find out all the latitude and longitude combinations, like all the pairs where you are having, right, more than one policyholder situated, right? Because we need to exclude those directly, right? So if like for example, if we see here, like if I find out, okay, 2020 is a place where 2 policyholders are situated, right? So you can directly eliminate these 2 because they are directly, violating the second condition, right? And obviously it will make our table much lesser, right? Okay, so let's start building this. So from this table called insurance, right? From this table called insurance, let me group by the lat column, the lon column, right? And then only keep those rows where having count of, right? So for each lat long group the count of, let's say, PID being the primary key, so non-null unique value. So if you just count the number of PIDs which is greater than 1, right? So this is basically all those latitude longitudes combinations where more than one policy holder is residing, and we need to exclude those latitude longitudes, right? So let me return the concatenated value, right? So what we can do is we can directly write concat the lat value, right? Then let's say there is a comma between them, and then the lon value, right? And let's alias this as location, right? Let me just run this, right? Obviously this is not complete, but let me run this. What is this returning? So 2020, right? So 2020 is a location of a city where more than one policy holders are residing, right? So we need to exclude all these latitude longitudes, right? So okay, so what we need to do is let's store this in a common table expression, right? So with city as, and this entire thing goes in parentheses. Okay, now this is one thing, that is we identified the latitude and longitude pairs of the cities where more than one policyholder is residing. The second thing that we need to do is we need to find out, that is what is the first condition, that the investments in 2015 should be equal to one or more other policyholder, right? So how can we get that? We can join this insurance table, right, on itself using this, and then keep only certain rows. Okay, so let me just write this and then I will explain, right? So if I write from the insurance table, right, let's alias this as I1, right, left join, right, the same insurance table, right, but this time aliased as I2. If you are joining a table on itself, you need to alias this as two different things, right? Otherwise your query won't work. On I1 dot investments in 2015 is equal to I2 dot investments in 2015. Okay, let me show like what I'm trying to do. So let me just copy this. Let us assume, right? Okay, so if I just paste it here, right, let us assume this is I1, right, insurance table 1, and this is I2, right? So when I say, okay, from insurance I1, let's left join on investments in 2015 from I1 and where is equal to investments in 2015 from I2, right? So how will this work? So here, oh, the cursor goes here. Okay, so 10, it will go and find out, okay, so there is 1, 2 and 3 matches, right? Similarly for 20, it will say, okay, here this is not a match, but 20 there is one match. Similarly for this, right? But because if you see like this for this one, right? So here if you go and find out the same match, essentially it is the same thing, right? So you don't need to keep that, because we need to find out the different policy holders in 2015 which have the same investments, right? So obviously like here, like if here these 5 columns come in here, right, after performing a join, and here we also have PID is equal to 1, 10, 5, 10, 10, right? So it does not make sense because it is just joining itself, right? So if I write where, right, where I1 dot PID is not equal to I2 dot PID, right? So it will say, okay, so here it will, after joining, it will have this, but it will only keep those rows where PID from insurance 1 is not equal to PID from insurance 2, right? So okay, let me just go ahead and build that join, and then we will be understanding this, like what will this do and what will it exclude. Okay, so this is how this will look like, right? So this is this part, joining these two insurance tables, right? Now if you look at these ones, right, so here it is the exact same thing, right? Obviously we don't need to keep these ones, right? So here again it is the same thing, because we need to find different policy holders who have investment same in 2015, right? So once we do this, where I1.pyd, so this table is from I1 and this is from I2, right? So I1.pyd is not equal to I2.pyd. So basically what it will do is it will remove rows like this, right? So here it will go out. Then if you look at this one, it will again go out, right? So again, if I look at, okay, so this one is again out because it does not make sense, right? Okay, and then if I look at this one, so okay, so this is also out. Okay, so these are the rows that will remain after doing this. Now we have satisfied the first condition, right? That the investments for different policy holders should be equal in 2015, right? So if you see for policy ID 1 and 3, the investments in 2015 is 10, 1 and 4 is again 10. Similarly for 3 and 1, right? 3 and 4, 4 and 1, 4 and 3, right? So we have this. Now the another condition needs to be that your latitude longitude part should not be from what we have calculated as the location where more than one policy holders live. So if we go ahead and rise and concatenated part, because we have the concatenated value, right, in the common table expression. So if we concat, if I write lat and then the comma, right, and then the lon value is not in, okay, one thing that why am I writing not in and not equal to sign, right, is like, let me just firstly complete this and then we will look at it. So return location from the city value. Now, so here we see that there is only one location that is returned from this common table expression 2020 where more than one policyholder lives. So if you write instead of this, if you write, right, if you write this one, so it will work in this particular case. But imagine there was another location where more than two policyholders would be there. So if you do return location from CTE, right, so it will have those two values. And here you are trying to compare one value with two values. So it will return an error. So that is why what we are doing is, so instead of writing not equal to, we write not in, right? So we write not in this one. Okay, so it will say, okay, this one should be from I1.lat and I2.lon, right? So here it will say, okay, so 1010 is not in 2020, right? So this will remain, this will remain. 2020, this will go out. 2020, this will go out, right? So if I remove these two, right, so this is what we are going to be left with, right? So now we have identified that there are two policy holders 1 and 4 which satisfy both of these conditions, right? And for these policy holders we need to find the total investments in 2016. If you see, like here we have repetitions, right, or two different rows, because like since we performed a join, so if there are more than one, same investments in 2015, you are going to have multiple rows. That is why we have this, right? So instead of doing that, what we can do is like simply write return distinct star. So since we are only, because we were just identifying the policy holders which satisfy both these conditions, and that is why we performed a join. So that is why, we are just returning the columns, these first 5 columns from the I1 one, right? Because that is what we need, because all we need is this column and just 5 plus 40, that is 45. That is going to be the total investments for all the policy holders which satisfies both the conditions in 2016, right? So that is what we need to do. Okay, so let me go ahead and remove this, okay, and let's see what we are getting is like what we are expecting from this, right? So let me just run this. Okay, so here we have 4, 3 and 1. Do you know why this is coming? Like what did I do wrong here? If you paid close attention, actually I did it deliberately. So here it should not be I2, it should be I1, because we need latitude longitude combination from the insurance table, right? So one insurance table, not the, like, you don't need the combination, right? So that is what we need to do. So if I go ahead and run this again, now we will be having, okay, so 4 and 1, these are the policy holders, right? So policy holders 1 and 4. So for these, what we need to do is, let's store this in a second common table expression. So CTE2 as this entire thing goes in second common table expression, right? And from this common table expression 2, what we are doing is, let's return the TIV 200. So TIV 2016, so investments in 2016, and for this we need the sum of it, right? Because we need the total investments by all the policy holders in 2016, which satisfies both these conditions, right? And then we also need to round this to 2 decimal places, right? So round to 2 decimal places. So we write round, right? So we write round sum and then to 2 decimal places, right? And let's alias this as, what is the output column? TIV 2016, right? So TIV 2016. Okay, so this looks good. Let me go ahead and run this to see what happens. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit it to see if it passes all the test cases. So yep, this passes all the test cases, and this is how we do it. Again, yes, it is somewhat medium difficulty, and we need to think about different stuff before you can actually write this code and develop this code. But if you pay attention to the logic, all we had to do was find so basically find all those cities where more than one policyholder lives, and we need to exclude them. Then what we did was, we self-joined this insurance table on itself, right? Just to find out that, okay, what are the different policyholders which have same investments in 2015, right? Because that is what the first condition says, that it should have the 2015 investment value as same as one or more other policyholders. So we did that, and then we excluded those policies which was the join on basically itself. Why? Because 1 and 1 does not make any sense, right? And then we are also excluding all those locations where more than one policyholder is residing, and then for them we return the distinct values from this column, right? Basically just to identify all those policyholders that satisfy those two conditions, and then based on that we just calculated the total investments in 2016, rounded it to 2 decimal places, alias this as whatever was required in our output, and that is how we do it. Let me know if there is a better way or a more efficient way to do this problem. Let the solution be in the comment section below, and until then I will see you guys in the next video.